All right, so let's try a couple examples with a different set of data. Here, I've created a brand new table, and this data represents data from a linear function. And so what we're going to do is we're going to use it to try to find the rate of change. Now, we're going to use that formula we came up with in the last video, and what we're going to do is we're going to start off by just picking any two sets of data. And the nice thing about it is you can pick any two that you want. For example, I can pick 1 and 7 as my first point, and 2 and 9 as my second point, as long as I keep track of which one's my first point and which one's my second point, because I want to make sure I don't mess up the formula. Now, once again, the formula is y2 minus y1 over x2 minus x1. And so what I want to do is I just want to pull the right values and put them in the appropriate places. In this case, y2 is the y coordinate for the second point, which is our 9, minus y1, the y coordinate from the first point. And in which case, when we subtract, that's going to give us 2, which makes sense because it's a jump of 2 from 7 to 9. Now let's look at the x coordinates. X sub 2 is the second x coordinate minus x sub 1. So 2 minus 1, which is 1, and 2 divided by 1 just simplifies down to 2. So we have a rate of change of 2, whatever this data would represent. Now, I'm going to use the same set of data, and I'm going to do it again, just because I want to show you that the nice thing about this is that it doesn't really make a difference which points you pick. I can pick two completely different points on this graph, say, for example, or this table, I should say, 0, 5, and 7, 19. Doesn't really matter. Because the nice thing is, as long as I use my rate of change formula, I'm going to get the same answer. So let's do it again. y2 minus y1. So my second y coordinate is now 19, minus y1, which is 5, over x sub 2, which is 7, over x sub 1, which is 0. And initially all the numbers look different because obviously we picked two completely different sets of data, but once I do the calculations, 19 minus 5 is 14, 7 minus 0 is 7, and 14 over 7 reduced down becomes 2. Same answer either way. And you'll find that for any linear function. You can pick any 2 points of data, use our rate of change formula. You should be getting the same rate of change regardless. And so that's how we calculate rate of change by taking data from a table.